welcome back to another fun and exciting lesson in pre-calculus. This is Mr. Bean, and we're going to today talk about polynomial division and factor theorem. But I want to point out first why even if you were working as a Walmart person who puts signs up in Walmart, you still got to know some mathematics. If you don't know what I'm talking about, take a look at this sign and you'll see. I think this is pretty funny stuff. In today's lesson, we're going to start off with long division. Remember this crazy stuff from 4th grade where you did long division? We're going to do it now, but instead of with just numbers, we're going to throw in some variables. This is also going to be a really important skill for you to know for your next unit, because we're going to work with some other weird things called slant asymptotes, and this will be needed in order to do this correctly. Now, when you do long division, notice what I've done here. I've written out the divisor here, what we're going to divide by on the outside, and then we do our long division symbol thing and write in here. But notice I've got some extra things going on. I've got a 0x cubed, a 0x squared, and there's no such thing in here. I put that in specifically because I need to have what I like to call a placeholder. So if we're missing any terms, start with the largest and count your way down. If you're missing any terms, put a 0 there in front of it as a placeholder. It will help us keep everything organized and work out a little bit easier for us. First thing you do is you're going to take this first term here, the x squared. You ignore everything that comes after it. You take the first term and you divide it in to the first term that's underneath this symbol. So how do you do that? Well, the answer to that is going to be 2x squared. But how do you do that if you can't just do this in your head? Think of it off on the side here as a fraction. I'm going to take 2x to the 4th and divide it by x squared. And if you can think of it this way, then it's just a matter of simplifying the fraction to get you the 2x squared. Okay, next step after you have that. Where do you get this thing from? Remember in long division, whatever you have up here, then you multiply to the front. So I'm going to take 2x squared times x squared, 2x squared times 2x, 2x squared times 1, and that's where all of this comes from. And then if you remember from our 4th grade lessons, what do you do next? You subtract that entire line. And if you subtract it, you will get this. Now, it might be beneficial to you, instead of writing the negative here, if you'll just distribute it to there, and then to there, and then to there, then what really is happening is you will get rid of the negative in front, and you'll just write the opposite sign here. It becomes a minus, and then that one becomes a minus as well. That might help you with the 0 minus 4 to get negative 4. And the 0x squared minus 2x squared to get the negative 2x squared. And then we bring down these here. The 3x and the minus 1 just come down. Now you start the whole process over again. Okay, everything basically you've learned on long division, we just did it. Now we'll start again. X squared here is going to go into negative 4x cubed. So it means this. Negative 4x cubed is going to be divided by x squared. And how many times does that happen? It goes in, this fraction reduces, and you get negative 4x. And then you start over. Negative 4x times x squared times 2x times 1. Just remember it's a negative. That will lead us to this thing here. If these terms are the same thing, then you know you did it right. Next step, subtract that entire line. If it helps, distribute the negative, and then you'll get this. And I know I'm going fast, and I apologize. This one can take kind of a while, so pause if I'm going too fast for you, and really you need to write small. I know I didn't give you much room on the notes, but that's because I'm trying to fit all the notes onto 2 pages. Next, what do we do here? We're going to go x squared is going into the 6x squared, and when that reduces, it basically those cancel, and you just get 6. So now we have plus 6. And then you multiply the 6 out again to the front, distribute it to those 3 things, write it out here, and you get 6x squared plus 12x plus 6. Subtract the whole line, and we get negative 5x. Again, you might distribute the negative if that helps you. Negative, make that a minus, make that a minus. Negative 5x minus 7. This is what is the remainder. Now, it's the remainder because x squared can no longer go into negative 5x. So this is our remainder. How do we deal with remainders? Like this. I'm going to write off on the side. Don't write this down yet, okay, because we're going to do it correctly. You add the remainder divided by whatever you were dividing by originally. So you take the remainder and divide by the original. So you have this little fraction at the end. The trick to this particular example is if you have a minus in front and a minus here, we're going to take the minus out and get this. The minus comes there, so then it's positive 5x and plus 7. That is your final answer to example number 1 in doing long division. Hopefully for many of you this was review, but I know it's one of the more challenging things that we do in Algebra 2. So to help you get one more chance at practice, you're going to pause this video and try number 2 on your own. And while you're waiting for me to do it, you can look at Mr. Press's weird picture. And here's your answer. You should have 2x squared plus 8x plus 9 plus, and then the remainder was a 1 over 2x plus 4. So I've got all my work shown here. You can kind of pause and go through that. If you don't understand what is going on here, this would be a good opportunity for you to write some big question marks on the side of your notes to talk to your teacher about in class on this one. Now we are on to synthetic substitution and division. Synthetic substitution just means we're going to take this number 3 and we're going to plug it into the x values, but we're not going to do it quite just that easily. I know it sounds like, why would we do something harder? Well, in some instances, synthetic substitution is actually easier than what's called direct substitution. If we just plugged it into the x, that would be called direct. So what I'm going to do here is I'm going to make this little weird symbol. I'm going to write the coefficients 2, -5. Now, 3 is going to go on the outside. Sorry, I know this is confusing. Write this down as I'm getting this, and I'll explain this. The number you're plugging in goes on the outside. The coefficients of the standard form polynomial go on this first row. I'm going to have 2 rows of things here. I'm going to have another row right there in just a second. So I go 2 is for the x cubed term. -5 is the x squared term. Notice there's no x term. So that means there's a 0 in front of the x term since it doesn't exist. So I'm going to put a 0 right there. Again, it's like a placeholder. And then once I get down to the constant, that is a 10. Okay, now here's how we do synthetic substitution. You remember this, maybe? You do nothing right here. You just bring the 2 straight down. Now what goes here? You multiply this number 3 times 2. 3 times 2 is 6. And then you add straight down. -5 plus 6 is 1. And now you do it again. 3 times 1 is 3. And then you add straight down. 0 plus 3 is 3. And you do it again. 3 times 3 is 9. And then you add straight down and you get 19. This is your answer. F of 3 equals 19. So you could also plug a 3 in, do 3 cubed times 2 minus 5 times 3 squared plus 10, and you'd also get 19. It works both ways. So now you're going to try the same thing with number 4. Don't forget to have your placeholders where you need them. Notice there's an x squared missing and a constant missing, so put the zeros in there. And while you're working on number 4, you can be accompanied by Mr. Sullivan's weird face right there. And your answer to number 4 is -82. So you can follow along here. You should have had a 0 in both of them, and you can follow along to see how I did this. Just always remember it's adding down the columns here, and you're taking the -2 and multiplying it. Okay, whatever you're plugging into the x, that goes there. Kind of a cool way of doing substitution. Now, what about synthetic division? Notice I'm talking about division here, not synthetic substitution. When can we use it? When we are dividing by a linear, this is kind of weird here, linear binomial. That was really sloppy. I probably should have typed that. Whoa, it's getting worse. Binomial. Okay, what in the world is a linear binomial? It's 2 terms, and it's just the variable is only being raised to the number 1. N is to the first power. Over here, x is to the first power. That's when you can use synthetic division. Now, there is a trick when there's a coefficient, but we'll talk about that in a minute. Let's do the easy one first. So what in the world do? We are going to make our weird little L. So again, this is different than substitution. This is division. You write out your placeholders here for the 2, -10. There's no n squared term, so we're going to put a 0. And then we go to the n, which is 30, and then 28. Now, what do we put on the outside here? You don't put down a -3. You're dividing by the factor of n minus 3, and so the trick to this is you put the opposite of whatever that number is on the outside for synthetic division. And then we do what we just did for synthetic substitution. Same process.
2 comes down. 2 times 3 is 6. Add that right there together in the column, you get -4. 3 times -4 is negative 12. Add that up, negative 12. 3 times negative 12, 24, negative 36. Add the column, negative 6. Then we go 3 times negative 18. Negative 6 is negative 18. Add that column, and you get 10. Now here's what's weird here. This is important.
This right there, that is the remainder. Use a different color here. That's the remainder right there, okay? So what did we do? We started with an n to the 4th. We divided by an n, so now our answer is going to be to the cubed, to the third power. It went from 4th power to 3rd power because we divided by n. So 2 n to the 3rd minus 4 n squared minus 12 n. See, we're just counting down in standard form. Minus 6 is the constant with a remainder of 10. So we say plus, the remainder is 10, so it's 10 over n minus 3. That is synthetic division. Going on to number 6. I'm not having you pause this one because this is a little tricky. Let's go ahead and set up our synthetic division stuff here. And we're going to put the coefficients to -5 and -12 right there. Which, by the way, if you saw the problem change while you're watching the video, that's because I just realized I had the wrong one up here. So I just switched it out. So this is the right one that should match your notes now. This is what we do here on the outside. If you could make whatever you're dividing by, in this case 2x plus 3, if you set that equal to 0 and solved it, you'd get -3 halves. That's actually what you put on the outside of this weird little L-shaped thing. See back over here? Whatever would make this become a 0, it's a 3. So it's actually called the 0. So whatever would make it a 0 goes down here. Okay, so let's do this. 2 comes down. You get a 2. Now here's what we do next. You're going to multiply it by -3 halves. What I would do is divide by 2 first, multiply by -3. So take 2, divide by 2, you get 1. Times it by -3, you get -3. Add straight down, -8. Okay, now let's do it again. Divide by 2, you get -4. Multiply to -3, you get a positive 12. Let me do that again. -8 divided by 2, and then times it by -3. Okay, and then you add that straight down and get 0. So hey, this is nice because the remainder is a 0. There's no remainder, so that's great news. And so then we go straight to our answer. It was an x squared. Now I'm going to show you this because watch, this is what's going to be wrong. So we go 2x, because we go down one level, minus 8. So the trick to this is, when you have a weird fraction, synthetic division only works if you take your answer and then you have, and then you have to divide your answer by whatever that leading coefficient was. I know this is really weird, but that's the only way synthetic division works when you have a number in front. You have to divide by that number. So my final answer then is x minus 4 with no remainder. That is the answer to this. Okay, I know that seems a little bit weird, but that's how it's got to work when you're doing synthetic division. So, or you could do long division if you don't want to do synthetic division on one like this. Okay, next part of our notes is the remainder theorem and the factor theorem. This is actually kind of, could be kind of common sense, and sometimes we make this harder than it needs to be, but just stay with me here. Think through this. If we have a polynomial that's being divided by x minus k, okay, we're just thinking this is just some number, okay, whatever that is. K is some constant. Then the remainder, we'll call it r, the remainder is going to be r equals f of k if you plugged in that number. Okay, so for example, if we divided by the x plus 7, then that means that the remainder, some r remainder value, what we're talking about after we divide it, the r is going to be whatever the number is if we plug in -7. You plug in the opposite, or like the 0. Okay, kind of crazy. That is the remainder theorem. That whatever the remainder would be is the same as if you plugged in -7, plugged in the 0. Okay, now the factor theorem. If we have x minus k, if that's a factor, again, same thing like up here, that's just some number right there, and it is a factor of the polynomial, whatever f of x polynomial is, if and only if, this is a key phrase here, if and only if, when you plug the number in, you get a 0. Okay, so in other words, if you get a factor and there's no remainder, if you substitute it in and you get a 0 value, then it is a factor. Here, watch. Think of it like this. If I have 12 and I divide by 4 and you get 3, what's the remainder? The remainder is 0. Okay, so these two things tie together. If the remainder, if it equals a 0, because that's the same thing as saying what the remainder is, see from up here? So if that remainder is a 0, or if we plug it in and you get a 0, then this original thing here was a factor. Okay, it'll make more sense as we do a couple examples with this. So here we have 1 0 that we're given for number 7. We're saying that 3 is a 0 of this whole big thing. What are all of the other zeros? Okay, so what that means is if 3 is a 0, then x minus 3 is a factor. So let's divide this thing by x minus 3, and then we can find all the other factors. So I'm going to use synthetic because I think it's easier to do.
2, negative 20, 66, negative 72. I'm going to put a 3 on the outside. Remember, it's the 0 that you put on the outside, or the opposite of the factor. And then we use synthetic. So 2 comes down. 3 times 2 is 6. Negative 14. I'm just doing the multiplication fast here. 3 times negative 14. Ooh, 30, 42. Negative. Negative 42. Add those together. We get 24. And then 3 times 24, 24, 48, 72. Positive.
Now, I knew this had to be a 0 right here at the end. It had to be. There had to be no remainder because we were told that 3 was a 0. Okay, so now what do we have left?
Now we have 2x squared minus 14x plus a 24.
And so now that we have that, we're looking for the other zeros. So if I can find all of the factors, then I will know what all of the zeros are. So let's factor this out. You're going to get
2 times x squared. Sorry about the space on your notes. You might need to be writing pretty small here. Plus 12. And then, so 2, and then we're going to factor this. X in front of both. Multiply to 12, a positive 12, and add to a negative 7. That is going to be 3 and 4.
So what does that tell us? It tells us that this factored there, and we also took out an x minus 3. So I'm going to throw on that other extra factor, the x minus 3, from the beginning. So what are our zeros? All of the zeros are 3 is a 0, which we had already. We have another 3, so we're doing a 3 2 times. So we have 3 is a 0, and the number 4 is a 0. So we only have the two zeros, 3 and 4, but 3 was listed twice. Now I'm bringing that up now. Can I help us with something else later in the lesson? How many zeros were there? 1, 2, 3, but one of them was counted twice. So we really only have 2, but we counted up 3 factors. And why am I bringing that? Because of that number right there, the degree was 3, and we have 3 zeros. Okay, I'm giving you a hint now because we're going to talk about that in a minute. Number 8 here, now you're going to try this on your own. Oop, that's a typo. I should fix it in your notes. That is supposed to be a minus 41 right there. So in your notes, if you're looking at your notes, it should be correct. And you're going to try this one on your own. Just remember, you're going to set up your synthetic division, and you're out of your 1/2 on the outside. So remember, there's something special you got to do with the 1/2. Look back at problem 6 to remind yourself if you're not sure about that. And while you're working on that one, you can have Mr. Kelly joining you with your progress while he's there with his biggest fan. Actually, that's probably his only fan. Okay, voila, I have no answer. And the reason I have no answer is because I can't factor this thing. You can look through and see what I did. I got the 2, negative 1682, and then I divided by 2 because of the weird 1/2 thing there, so I get smaller numbers. But this doesn't factor. So what you have to do instead, if it doesn't factor, sometimes people are like, I don't know how to solve this. Yes, you do. You use the quadratic formula. Okay, so we're going to go, I'll write out the quadratic formula here, solve that if you didn't get that far, and I'll have your answer appear here now. Just a sec. Pause now if you didn't do that. Try the quadratic formula. So with the quadratic formula, you should have ended up with this. 8 over 2 is 4. This becomes a negative 100, and so you get the square root of negative 100 and get 10i, but it's 10i over 2. So you get 5. All right, so you need to work out that a little bit if you're not sure. So there we have how many zeros? We had the 1 that was the real, 1/2, and then we have 2 imaginary zeros. So this is 2 zeros along with the 1/2 for a total of 3 zeros, and again, the degree was a 3. So what can we conclude? Look at number 9. If x equals 3 is a 0 of some function, what else can we conclude? I want you to write these 3 things down. I got 3 things for you. If x equals 3 is a 0, then x minus 3 is a factor. If x equals 3 is a 0 and x minus 3 is a factor, then x equals 3 is also an x-intercept on the graph. And if x equals 3 is an x-intercept, we also know that x equals 3 is a solution to this equation of when does y equal 0? Y equals 0 when x equals 3. Okay, these four things are all interchangeable. Very important to be able to know they all mean the same thing, and you can interchange them however you want. That's a very useful thing as you're going through a lot of the problems we'll be doing today. Next, problem number 10. I've given you a graph here. You have the window so you can tell what the scale is, and you're supposed to figure out what all of these zeros are. Well, what are all of these zeros? You can't just tell by looking at them, and even if you use the calculator and graph it, you're going to get a decimal answer. And the key word here is exact. For example, maybe one of them is the square root of 37. Maybe that's one of these roots. It's not, but what if it is? A calculator is not going to give you that exact. It's going to give you a decimal approximation. So if we want exact, we're going to have to use some of our cool algebra skills, and that is use one of these zeros. I can't tell where that one is. I can't tell that one. I can't tell that one. But one of them, I'm always going to make it obvious for you. That is at 1, 2, 3. So I have a 0 at x equals 3. Well, if that's a 0, that also means that x minus 3 is a factor. And we could divide that from this, because if we can find all the factors, then we have all 4 zeros. Notice there's 4 zeros because the degree is 4. Okay, so let's do it. Let's divide it out. So we're going to go 3.
Negative 8, negative 12, 24, and 9. And then over here I have 3 on the outside. Now I'm going to pause and have the rest of this part appear so we can get what we're going to work with next to factor.
Okay, here's the divided polynomial now. And write this down if you don't have that. That's just kind of, I didn't want to take up a bunch of video time to do that we've already been practicing. But now we have to factor, which we learned a lot of this stuff in the last lesson. How do we factor something with 4 terms? Try factor by grouping.
So let's see what these first two have in common. We've got an x squared that we could pull out and make this a 3 plus 1. 3x plus 1. And then here I can pull out a negative 3. And what am I left with? X plus 1. Perfect. Whoops. 1. Perfect. No, 3x. Sorry. 3x plus 1. So since these are the same, I can then go down to 3x plus 1 times x squared minus 3.
Okay, so remember the whole point of this was to be able to try and find the zeros. And we know that x minus 3 was also a factor. So what I have listed here are all of the factors of this original polynomial. So what are the zeros? You take each one of these and set it equal to 0. So you're going to end up with, our zeros are going to be negative 1/3. You're also going to get a 3 from this one. What about this one? When you take x squared and set it and add the 3 to both sides, and then you're going to get that x equals plus or minus the square root of 3. So we have how many answers? 4. We have those 2 and that one. There's our 4 answers. Negative 1/3, 3, square root of 3, and negative square root of 3.